Roman kitchen gardens often went weeks without a single drop of rain, yet they did not fail. The reason for their incredible resilience in the face of Mediterranean summers is not what the ancient farmers put on top of the soil. It is what they meticulously buried under it, arranged in a very specific, highly engineered order. When modern archaeologists excavate the preserved remains of ancient agricultural terraces and domestic courtyard gardens from the classical era, stretching from the Italian peninsula across the arid landscapes of North Africa, they often find something highly peculiar resting at the very bottom of the soil profile. They do not just find uniform dirt extending down to the bedrock. Instead, they find deliberate, meticulously engineered layers of coarse river gravel, thousands of pieces of broken terracotta pottery, and fine sand, stacked intentionally beneath the root zones of the crops. The standard, modern advice today, when a terracotta pot accidentally breaks on your patio, is to throw the sharp pieces away in the trash, discarding the material. Or, perhaps, you might toss a single, curved shard over a drainage hole in a new pot to keep the loose soil from falling out. But the ancients deeply understood a fundamental physical principle regarding fluid dynamics that modern backyard gardeners almost always overlook. They recognized through intense, multi-generational empirical observation that the earth itself could be physically engineered to act as a reliable battery for storing water. By deliberately arranging specific, naturally occurring materials horizontally beneath the surface, they successfully created a passive irrigation system that captured the intense, heavy, wet season rains and held that moisture securely in reserve for the punishing dry weeks ahead. This was not a mystical ritual, an accident of geography, or an empty superstition based on moon phases. Published archaeological and soil research shows that these deliberate, labor-intensive stratifications directly manipulated the downward movement of water through the ground. They literally built a structural system that refused to let gravity steal every precious drop of moisture, ensuring that the valuable crops planted above had a constant, slow-drip supply of subsurface hydration long after the visible surface turned to cracked, blowing dust. They conquered the drought not by carrying more water, but by changing how the earth held the water that naturally fell. When you observe a modern garden in July, the soil is fighting a losing battle against the sun. But the Roman design insulated the water, hiding it in a physical vault that the sun could not reach. Let us systematically reconstruct this ancient layer, working step by step from the bottom up to understand exactly how the physical mechanism works to defy gravity and hold water in suspension. The critical foundation of the entire system is a thick layer of coarse, impermeable material, often heavy river gravel, large, smooth field stones, or chunks of dense rock laid down to a thickness of several inches. Above this foundational base layer sits the absolute most critical component of the entire design: a dense, thick, overlapping strata of broken, unglazed terracotta pottery. These ceramic pieces, known as amphora fragments, discarded storage jars or shattered terracotta roof tiles, were gathered in quantities from the vast waste output of Roman cities. These vessels, once used to transport olive oil and wine, were endlessly recycled into the earth. These ceramics were not just thrown into the trench randomly or dumped haphazardly from a cart. Archaeological records from Roman agricultural sites document that they were carefully packed, fitted, and layered like a puzzle to create a continuous, highly structured artificial horizon, often stretching 4 to 6 inches thick across the entire bed. The curved pieces were often laid like roof tiles, creating overlapping scales of clay. Finally, a smoothing transition layer of coarse sand was carefully laid directly over the jagged pottery, effectively locking it in place, followed by the actual, rich growing soil piled on top. When heavy rain violently falls on this engineered bed, the water naturally percolates down through the dark topsoil. Normally, in a deep, uniform column of natural earth, gravity would continue to relentlessly pull that water deeper and deeper into the subsoil, eventually moving it out of the physical reach of the shallow plant roots. But when the falling water hits the engineered transition layers of sand and packed terracotta, the physics of the subterranean environment fundamentally change. The unglazed terracotta is highly, microscopically porous. It is essentially a rigid, rock-hard sponge made of fired, mineral-rich clay. The firing process locks the clay particles into a rigid matrix, but leaves millions of microscopic voids between them. As the sheet of water washes over the overlapping ceramic fragments, the millions of microscopic pores inside the terracotta aggressively absorb the moisture. The downward flow of water is abruptly, temporarily halted, sucked inside and securely trapped within the physical, unyielding structure of the buried pottery. To understand the immense capacity of this terracotta layer, consider that a single unglazed pot can hold up to 15% of its own weight in water purely within its microscopic internal void structure. When you scale that up to an entire subterranean layer spanning a garden bed, you're talking about hundreds of gallons of water suspended in a solid state, held firmly against the pull of gravity by the sheer force of microscopic adhesion. The water is safe from evaporation because it is shielded by the thick soil above, and it is safe from gravity because it is locked inside the rigid clay matrix. The ancients essentially built an underground cistern that never needs to be manually pumped. Why exactly did this specific, labor-intensive arrangement work so well for centuries across the ancient world? It fundamentally comes down to the undeniable physics of capillarity and the intentional creation of a perched water table. The physics here is settled. When a fine-textured material, like your rich, compost-heavy growing soil, sits directly on top of a very coarse, airy material, like gravel or large, gaping broken pottery, the descending water hesitates significantly to cross the boundary. The invisible capillary tension holding the water tightly in the smaller, microscopic pores of the topsoil is actually stronger than the force of gravity trying to pull it down into the open-air gaps of the coarse gravel below. This physical tension causes the descending water to pool slightly just above the coarse layer, effectively creating a temporary, highly saturated zone known as a perched water table. But the true, enduring brilliance of the Roman design was the deliberate inclusion of the terracotta exactly at this interface. The unglazed pottery sits precisely at this critical transition zone. It rapidly absorbs the pooling perched water, filling its internal microscopic pores to absolute maximum physical capacity. It acts as a sponge that captures the stall in the water's downward momentum. When the inevitable dry days finally arrive and the intense sun begins to bake the topsoil, the surface quickly dries out and cracks. As the thirsty plant roots desperately pull moisture from the surrounding earth, a sharp moisture gradient is actively created in the vertical soil profile. Nature abhors a dry void next to a wet sponge. The bone-dry soil above acts exactly like a powerful wick on an oil lamp, slowly, steadily pulling water back up from the deeply saturated terracotta layer through continuous capillary action. The rigid terracotta acts as a permanent, solid-state reservoir that cannot be crushed by heavy soil compaction or destroyed by burrowing pests. It continuously feeds life-saving moisture upward to the thirsty roots above, transferring the water slowly over days and weeks. This specific mechanism only works with unglazed terracotta. A shiny, glazed pot has its vital pores permanently sealed with glass during the firing process, and will not let a single drop of water through its impenetrable surface. It must be raw, porous, fired earth. The terracotta is essentially a physical translation of the soil itself. It is clay that has been rendered indestructible by fire, yet it retains the precise hydrological behavior of the natural earth. This means it speaks the same physical language as the soil around it, readily exchanging water back and forth as the gradient shifts from wet to dry and back again. It is important to distinguish exactly where the ancients succeeded through deliberate, calculated engineering, and where they ultimately benefited from the happy, unseen accidents of physics. Let us look closely at a detailed cross-section of this layered system in active operation. In a vertical cross-section of the Roman bed, you see the dark, rich, crumbly topsoil heavily penetrated by deep, aggressively searching root systems. Directly below that, you can clearly see the thin transition layer of pale sand, and then the thick, chaotic band of overlapping, curved red terracotta fragments. Below that sits the pale, sterile, coarse gravel. The undeniable engineering brilliance of the ancient farmers was recognizing empirically that water reliably moves upward through dry soil if there is a saturated source waiting below. They saw the results of natural layering and replicated the architecture intentionally. The happy, unseen accident was that raw terracotta, born directly of the fired earth, shares the exact, precise capillary properties needed to interface with the surrounding soil matrix. Studies on ancient irrigation find that the microscopic pore structure of fired clay holds water tightly enough to prevent gravity from instantly draining it away into the subsoil, but loosely enough that the powerful osmotic pressure of a thirsty root system can easily extract it when desperately needed. If they had mistakenly used smooth, round river stones instead of porous, fired pottery in that middle layer, the entire system would have failed spectacularly. The dense stones would not absorb a single drop of water, and the large, gaping air gaps would have drained the topsoil too quickly, severing the capillary connection and leaving the plants to wither. The terracotta is the crucial, functioning bridge. It is the solid-state reservoir of the ancient world. In a working cross-section during a severe drought, you can visually trace the dark, damp moisture wicking steadily upward from the saturated red clay shards directly into the dusty brown earth above. The roots aggressively wrap themselves around the damp shards, physically hugging the terracotta to extract the microscopic beads of moisture, maintaining a stable, life-saving zone of hydration that ignores the aggressively arid conditions raging on the surface above. When you dig into such a profile after a month of no rain, you will find the surface dust dry. But the moment your trowel scrapes the red pottery, you will feel the undeniable chill of trapped water. The terracotta shards will literally feel heavy and cold to the touch, a stark contrast to the burning heat of the air. This temperature difference is the physical proof of the system working, as the evaporating water cools the ceramic matrix, creating a microclimate of stability beneath the soil. If you are fascinated by the way ancient engineering aligns with modern soil physics, make sure to subscribe. In an upcoming video, we will look at how burying cotton towels takes this capillary action to a different extreme. You do not need to build an acre-wide archaeological terrace to use this exact physics in your own modern backyard. You can easily replicate the powerful Roman layer in large container pots, deep wooden raised beds, or challenging, chronically dry patches in your in-ground garden. Start immediately by saving every single broken, unglazed terracotta pot you have. If you do not have pots, unglazed terracotta roof tiles or unglazed brick fragments work exactly the same way. Always wear safety glasses and wrap the pots in an old towel before taking a heavy hammer to them. Carefully crush the ceramic materials into jagged pieces roughly the size of a large coin, ensuring you have plenty of varied angles, curves, and rough edges to maximize surface area. When preparing a new raised bed or a large half-barrel planter, dig down below the active, expected root zone of your plants, usually about 12 to 15 inches deep from the final surface level. Lay down a thin 1-inch base of ordinary river gravel to ensure absolute final drainage at the very bottom. Then, follow it with a dense, heavily overlapping 2 to 3 inch thick layer of the jagged terracotta fragments. Ensure they are packed tightly enough that there are no gaping holes, but loose enough that they form a jagged matrix. Cover the jagged pottery with a light dusting of coarse builder's sand to prevent the fine organic soil from immediately washing down and clogging the macro gaps between the shards. Finally, return your rich, compost-heavy growing soil on top to fill the container up to the planting level. By meticulously doing this, you are manually, deliberately constructing a permanent subsurface battery that will never degrade, rot, or break down over time. It will last as long as the Roman ruins themselves. Published records from irrigation studies suggest that the terracotta reservoir can provide up to 21 days of steady capillary moisture during an extended dry spell, long after the exposed surface has severely cracked and dried into dust. You are taking a common, frustrating waste product, shattered, broken pots that the standard, modern advice actively tells you to discard, and turning it into a permanent, structural, highly engineered ally for your garden's long-term water retention. Deep-rooted plants like tomatoes and peppers will specifically seek out this layer, dropping taproot straight down to drink from the ancient battery. They will thrive in the heat while the rest of the garden struggles, because you took the time to build the soil the way the Romans did. Do you currently throw away your broken terracotta pots, or have you ever tried burying them in your garden beds? Let me know your experience in the comments.